All right. Good morning, everybody. Welcome on in. Here we go. So, going to talk some statistics. So, a couple things. Let me get back over into here into Canvas. Basically, what happened was, oops, let me change this setting here on Zoom. I finally got it where it doesn't have to have a waiting room. Don't want that on. There we go. Okay, so welcome on in. I'm going to show you a couple things today. So basically what happened was, as you know, well, let's see. This is the Tuesday, Thursday class. Yeah, so your class got canceled when I was sick. So as you know, I wasn't feeling well. But then I was getting emails of people asking me about their questions for the survey, which is great. That's good. That's a good thing. But I was ill, and so I wasn't really able to respond to those. So I didn't really feel it was fair when people were trying to get help, but then I was too sick to respond to them, to then have them, submit those questions when they had been trying to do better. Because it's really important that these questions that you have for your survey are just as good as you can get them, right? It's like when you write an essay and you write a rough draft, a lot of times people just want to turn that rough draft in. But when you come back a couple days later and read it, you go like, oh, this is garbage. No wonder my teacher's giving me C's when I turn in a rough draft. So you read it again, you make it better, you refine it a few times, and then all of a sudden, you turn that essay in, and all of a sudden you're getting an A on your papers instead of getting C's, because you took that time to refine them. It's the same thing with these questions. It might seem real easy. Oh, I have a question. I just want to ask it for part of my survey. But if you ask a question that is not really well thought out, your data coming in is going to be a mess. You might not actually even get usable data. Sometimes that's the case. You ask a question and the data that comes in is bad and you can't fix it. What are you going to do, right? A lot of times in life we can go back and fix problems, but when you've collected your data, now what? Like your data's bad. You have bad data. What are you going to do about it? You can't, generally you're not going to be able to fix it. Occasionally you can fix bad data, but almost all of the time, if you picked questions poorly and got bad answers, you now get to deal with bad data for the semester, or if it's not in this class, then you'd have bad data that you're trying to use for your business or whatever, research or whatever. So I really wanted to make sure that people had a chance to get their questions properly proper. So I responded to the people who emailed me. I've had a number of people show up to office hours to ask about their questions, and I helped those people. So hopefully those questions are going to, get streamlined. So I changed the date of the survey projects to today. So if you have looked, if you left a post before, just go back. I think you can still edit your questions or your responses. So just go back and edit them, because it's really in your best interest to have the best questions that you can. Like, trust me, it's going to make the rest of your work a lot easier, and your work is going to look better, which is what you want, right? If you're going to spend the whole semester making a project, you want it to be good. So I'm giving a little extra time for, because some people emailed me or came to office hours and asked about it. I wanted those people to be able to update their questions. And then any of you who already submitted your questions, but you've kind of realized since then, oh, I could do this a little bit differently, go ahead. I really want, when I make the survey, to have the best questions for people, because that's going to set you up to have the best projects, right? A bad question can make it real hard from the start. Great questions are going to kind of streamline it so that you'll be able to sail right through each individual assignment that we have that's related to the project. So I do have I think I have office hours today right after this class. So, and as always, you can just stick around after class and ask me those questions that you're interested in. And then, or questions that you have. So you can ask me those questions, and then you can make sure that you post to here or change your old response. I think you can go in and edit it. If you can't, just leave a new post, right? It's just better that I get the good quality questions in there. It's going to make everyone's life easier. You're going to make better projects. I'm going to be watching better projects. If I have a choice between watching a good project and a bad one, I'll take a good project every time. So we'll do that. Okay? So, and again, really think about your responses. This is what I would encourage you to do. Think about your responses. Think about the type of answers that you want people to give, right? And think of, kind of give the extreme version, like coming in and asking a question, what is your favorite childhood memory? That's going to be a mess. You're not going to be able, there's zero that you can do with a question like that. But if you come in and you ask someone, how many hours a week did you work before COVID? How many hours a week do you work during COVID, right? Those, you now have two numerical questions and you've been specific. Notice I used a unit, hours. If you just say, how much do you work? There's different, people could answer that in different ways. People could say, oh, I work 5 days a week. Some people could say, I work 40 hours a week. So if you're reading your questions, ask yourself, should I put a unit in here? Because the answer is probably yes. If you suggest a unit, people will probably use that unit most of the time. But if you don't, then you might get different types of answers, like I just said, where people tell you either days or hours, right? Those are different ways of answering that question. Sometimes it's obvious. Like if you ask someone their age, they're probably not going to respond to you in months, right? They're probably not going to say, oh, yeah, I'm 972 months old. That's pretty rare. Probably people are going to answer in years. But a lot of the times you want to stop and think, height. People answer height different ways. I've seen it because that's a question that usually gets asked. What's your height? And then people will put, oh, I'm 5'8", and then they'll use the tally marks. I'm 5. Let's see, what foot is the shorter one? So it would be 5-8 dash. And then some people will put, oh, I'm 68 inches tall. So you now have 3 types of answers coming in. That means you're going to have to go through and modify them all. So just put some thought into your questions. Really, this is one of those spots where putting the effort in now is going to save you a lot of work later. Okay. So like I say, some people emailed me. I don't know how many emails I'll be able to respond to between now and the end of the day because I'm actually kind of booked for the day. But you're welcome to come into office hours and talk to me if you want. And of course, you should have your groups kind of figured out, and you can talk to your groups about it because you should all be working on this together. So hopefully you're getting a little bit of feedback in that way. Okay. Right. So we talked about sort of displays of data, good displays of data, misrepresentations of data. Okay. So like I say, anyone who has questions, come see me after class and we'll talk about it. And that's some of the people that came to me had really good questions. They obviously put some thought and effort into it. And did like a good job, but I was able to sit down with them and say, oh, this one question, if you worded it a little bit differently, it's probably going to go a little bit smoother. Oh, this other one, it's a great idea, but if we word it this way, I think it's going to be more helpful to you. And then sometimes I was able to say, ooh, this is a really good question. What if we ask a second related question? Then now it's going to allow you to set up a correlation later on with a scatter plot. So, a little bit of feedback, I think, is helpful. Even if you think you've done a really good job, which many of you did. Many of you came to me with good work. Sometimes a couple minutes of looking at it between you and me, we can make it even better. And then, I think some people kind of learn stuff where they go, oh, I see. That's a better question. And they kind of help put some light on it. Okay? So stick around after class if you want some help with that. Okay, so we're kind of getting into Chapter 3 now. If you still have questions from Chapter 2, feel free to bring them to me. But I think that stuff's more or less straightforward. If not, if you're confused, that's totally fine. But come talk to me about it. So we start getting into Chapter 3, where we start getting into like statistics, where you're going to be crunching numbers. And I just want you to remember, this isn't a situation where you just say, well, I'm going to have StatCrunch crunch some numbers and then I can walk away from it. The most important thing in this class is for you to interpret the statistics, okay? Interpreting the statistics is why statisticians are important, not being able to crunch numbers. There is tons of software out there, including StatCrunch. StatCrunch is not just an educational piece of software. It's literally a software that some people pay a subscription to just always have. So if you're someone who once or twice a month you use some statistics for your job, then it's probably worth it to buy, I think it's $15 a month, and you could get your work to pay for it if they expect you to do statistics, and then you have some statistical stuff. Excel can do some statistical stuff for you, but Most places are moving away from Microsoft Office. Some still are, but schools were a big one for a long time. Schools are moving away from it because they're like, well, we have Google Sheets, so why would I pay for Excel when I can get Google Sheets for free? And the answer is, well, there's a few things that, like, Excel can do some statistics and stuff, and school districts go, I don't care, we don't have any money. So our teachers are going to start using Google Sheets. So Excel can do some stuff if you happen to have that on your computer. You're going to have to watch some videos on YouTube about how to do it, because I don't use Excel, so I don't really remember how to do it. But, it's not that hard. You just go to, you guys know how to look for stuff. You go to YouTube and you put Excel, histogram, and there's going to be someone with a video that's making a histogram on Excel, and you can watch them do that. But there's a lot of statistical specific software, and a lot of it's kind of falling by the wayside over the years. There's one called Minitab. There's different programs. StatCrunch is big right now because people learn it as students, and also it's pretty cheap, $15 a month, and you can just turn off your subscription. It's like a lot of times, like, in my house, at any time we've got like 3 of these subscription services, Hulu and HBO and Netflix and stuff like that. But then when you kind of run out of one, you're like, there's nothing on Netflix right now. You shut it off for a couple months, and then you wait till stuff comes back on Netflix, and then you turn it on again. You can kind of do that with StatCrunch, where you're like, ooh, for the next few months at work, I'm going to need statistics. Let's get a subscription to StatCrunch. And then when that project's over and you're like, I'm probably not going to need statistics for the next year, then you turn it off, right? You don't have to pay for it. So that's kind of nice, rather than shelling out a huge amount of money for software. There's also a programming language that was designed around statistics. Like, it's specifically for doing statistics. I think it might be, I don't remember if it's, I don't want to say that. I was thinking maybe it was a derivative of Python, but now that I think about it, I don't think it is. But it's an entire software that's all designed so that you can just do high-level statistics. So like right now, people who do statistics as their job, and I kind of referred a minute ago, like there's a lot of people who do a little bit of statistics in their job, so you just need something like StatCrunch. But people who would be considered like statisticians, who are doing heavy statistics during their job, many of them use that programming language because it allows you to do everything exactly how you want it. Not that it has to fit into what was programmed into StatCrunch or something, but you can get everything precisely how you want it to be. That and for anybody who's interested, that programming language is called R, like the letter R. Like R, that's like a silly name for a programming language. And we'll talk about this later. When we get to correlation, when you want to measure how closely 2 different variables are related, that measurement that we come up with is it's the letter R. We say R equals 0.0054 or R equals 0.895 or something. It's the letter R. So they named the programming language after that. So there's lots of ways of doing actual work. Some of you who are very familiar with programming languages, you probably wouldn't have much difficulty jumping into R. I think it should be like a free program. You can just download it and start compiling different stuff. You don't have to, if you're not familiar with programming languages, you don't have to use R or anything, but it's there for you if it's something that you want to do. You do have StatCrunch freely available to you through the through the license that you got. Hopefully everyone has got their license from the bookstore. My second class of statistics started yesterday, so there's going to be a big influx of people trying to get those licenses. So hopefully they don't run out in the bookstore and then you end up without it. And then notice I think I didn't have this open before, but StatCrunch is open on the left side, and I believe if you click that, you should just be able to go right into StatCrunch, and it should let you use it. But I'll have to let me know if it doesn't work right. If I don't have it set up right, let me know and I'll look into it. Right, so we're going to get into actual number crunching. There's lots of different ways to crunch numbers, like I mentioned. You can use StatCrunch, you can use R. If you have a TI-84 calculator, which some of you do, you can do most of the things we're going to do in this class can actually be done on a TI-84 calculator, although I don't know why you would do that over StatCrunch. We sometimes used to have students do that because if we're all in the classroom, then you don't all have computers in front of you, right? So we'd have people check out the TI-84s, and then you could like do the things that we're doing right there in the classroom. But the reality is, since most of you are now in front of computers when we take class, then StatCrunch is usually a better option over the TI-84. I'll have to figure out what we're going to do when we go back to the classrooms. We'll see how that works. We'll see how that goes. Okay. So what do we want to do when we measure sets? What are the different ways in which we can measure a set, a data set, right? That is, you have some type of set. So I'm a mathematician, so we sort of think in sets. So sometimes, you won't hear statisticians necessarily mention sets. They'll talk about data, but that's essentially what data is, right? In your algebra class, you were usually concerned about one number or maybe two numbers, right? You would solve an equation, and most of the time you would end up with one answer, x equals 7, okay? Or say it was a quadratic, you might solve that equation and you'd end up with x equals 2 or x equals -7, okay? So really like two numbers. Well, in that case, it's real clear. If x equals 2, x equals 2. End of the story. What more is there to talk about? X is equal to 2, right? There's the end of discussion, right? But when you have a set of things, like when you collect data, you're all going to put your survey questions out there, and you're all going to answer the survey questions. So you're going to get back, say, 40 responses. In an ideal situation, everyone would respond. You're going to get back 40 answers to your question. Well, what are you supposed to do with 40 answers? That's very different than getting one answer back and going, well, I guess that's the whole story. Now you've got 40 numbers that you have to deal with. So how do we measure those things? And what is a good measurement? What is a bad measurement? How many different ways are there to measure it in a good way? Whatever that means, some kind of a good measurement. What would that be? And it turns out that we have different measurements that we can apply to our data, and depending on what your data represents, some of them may be more helpful than others. So it's not, I know this is frustrating for students in statistics when I'm like vague in my answers, but that's because in statistics, there's rarely just a right and wrong answer, right? There is numerous ways that you can do a thing, and it may be helpful to do it in those different ways. Right? It may be helpful to do it it may be helpful for you to have two completely different histograms of the same thing when you're doing your project. You might say, well, here's what the data looks like when we break it up into 10-year increments by decade. And here, if we break it up into 5-year increments, we actually see a very different picture. And then by comparing those pictures, you can come up with something interesting. So when students say, well, if I'm making a histogram, what's the right number to break up my groups into? Should it be 5 years or 10 years? Well, it just depends. It depends on your data. And even if two of you are doing the exact same question, you ask a group of people about some data and someone else asks some group of people about the same question, but you have different data. It could be that one of you chooses 5 years and one of you chooses 10 years, and that's the right way to do it, or the best way, I should say. There isn't really necessarily a right way. So it's vague. That's why with statistics, you have to play with stuff a little bit and figure out what works. The good news is you'll do it in StatCrunch. It takes a couple seconds to try numerous histograms and go, yeah, this is the one I like the most. That's the one I'm going to use in my project. But there's no golden answer that says, whenever you do a histogram, always do it exactly this way. Always have your bin size will be 3, and, it just doesn't work that way. You have to have your critical thinking cap on, sort of ready to do some logic and reasoning and critical thinking and look at your work and be able to put some work in. That's part of it too. As students want to press one button and say, okay, I did the work and I'm leaving now. Sometimes it takes sticking with it and trying a few different things and going, oh, this is the best way to do this. Okay. So there's no like perfect answers in statistics about, whenever you do this, you should do exactly this. Anytime you come up with a rule in statistics, there's someone out there who's breaking that rule. The key is you have to know when is the right time to break those rules, right? When is the right time to say, I have a really good reason why I'm doing it differently in this case, and you have to be able to justify it. Otherwise, you end up looking like you don't know what you're doing, okay? So two major measurements that we want to look at when we talk about statistics. Well, it kind of makes sense. One thing we'd want to know is, where is the center, right? And that's what most of you are asking when you ask when an exam takes place in a class, and then someone inevitably asks, what's the average? And what they're really asking is, what is the mean, right? But they kind of think they're measuring the center, right? They think, oh, well, the mean is right in the middle, right? So half the class is above that and half the class is below that, which is actually false. That's not true. But that's kind of what the line of thinking is. So if you're above the average, then you go, oh, I'm in the top half of students. Okay. And if you're below the average, you go, oh, I'm in the bottom half of students. That's wrong, right? So that's a perfect example of people using statistics incorrectly. And then drawing an incorrect conclusion. You can have, we could take tests. In fact, usually it's the case where you could take test scores and more than half the class scores above the average. That actually happens a lot because you usually get a couple people that come in to take the test that are unprepared and do really, really bad, like maybe 5%, 7%, because they literally didn't do anything, no homework, didn't watch any videos, anything. They just showed up and took the test. Well, that lowers that average. Well, as that average gets lowered, more and more people now place above the average. So, if you're ever in a class and someone asks, oh, what's the average? And they're thinking, oh, that means since I scored above the average, that means I'm in the top half of the class. It doesn't mean that at all. Like, we'll take a look at that in a little bit. So when we want to measure the center of our data, there's not even just one way to do it, because there really is no perfect way to measure the center. Like, I just gave one example of how using the mean to measure test scores is not a good way to do it. But we still have the thing called the mean, what most students think of as the average, which we're not going to use that word in here because average, when you say average, people think different things. Some people think median, some people think mean, some people, it's not clear. It's ambiguous. So we will use the word mean when we're talking about what most of you think of as average. We also have other measures of center. One is called the median. The median is oftentimes a much better tool to use than the mean. Not every single time, but oftentimes it's better. But most people don't think about the median. They just immediately ask, what's the average test score? When really what they should be asking is, what's the median test score? Because if you ask the median and you're above the median, then you are definitely in the top half of the class. If you score below the median, you are definitely below the bottom half of the class, which is usually what students want to know. So that's a perfect example of how the public at large uses statistics incorrectly because they never learned statistics, so they're using it wrong. Right? So let's look at a few things here. Have my book so I can kind of keep up with stuff. So let's take, for example, let's open StatCrunch here. So here's StatCrunch, and it just kind of, you might look at it and go, that just looks like Excel or something. It's a little bit different. I mean, it looks similar. It's actually a lot different when you get into it. The way you're going to look at this is generally your columns. So columns, in mathematics and stats, we have rows and columns. Rows go across. Columns go up and down. So think about like rows of seeds on a farm. Those are horizontal. Columns, like in buildings in front of a bank, a column is vertical, goes up and down, right? So when I talk about columns, that specifically means vertical. When I talk about rows, that specifically means horizontally. That's going to be the same for those of you who have to learn matrices in a math class sometime. Same language. Rows are horizontal, columns are vertical. That's pretty standard throughout mathematics and statistics that we use those words that way. So basically, you're going to have the columns are your data sets, right? So this is variable 1. So this is all the values that variable could take on. And then each column is going to be a different set of data. Basically, each column is a data set. So what will happen is I'll create a survey out of all your questions. You'll all take it. And then what's going to come back is something that's going to look like this, except each column is going to have types of data in it. You'll see this variable 1 will have a bunch of data. Variable 2, bunch of data. And there'll be however many I don't know how many questions we're going to end up with. I've had as few as like 80 questions on the survey, and sometimes we've had like 120. So it just varies. But we'll have each of these columns will correspond to the data set for a question that you asked as part of your survey. Okay. So what you'll do is you'll find that question, and then you'll come here and you'll find the corresponding column, and then you go, okay, that's my answers to that question, and then you will do analysis on that data. So for instance, let me just make up some data right here. Let's say here, let's just make up some test scores. So we've got, let's see, 72, 91, 84, 49, 15, 98, 77, 78, 73, 75. Okay, so we'll just make that up for now. So let's just say that's a hypothetical class. That's our test scores for the class, small class. We've got some data right there, and I want to run some analysis on this. Maybe I want to measure the center, right? So then we think, okay, what about the mean? So what is the mean? If you remember, and this is all in the lessons that you'll be watching throughout. The mean is where you add up all of the values, and then you divide by the number of values. So here we have 10 values. So I would add up these 10 numbers, and then I would divide by 10. Okay, that's the mean. And the mean has the mean can be very useful. The problem is the mean sort of shares, and it's not really the mean's fault, it's how people use it, but it's kind of like pie charts, where pie charts can be helpful, but people overuse pie charts and they use them in places where it's inappropriate to use a pie chart. And so then the pie chart is sort of, frowned upon a little bit. The mean is not frowned upon. The mean is very helpful, but I would say it shares that same distinction of people use the mean when it's inappropriate to use the mean. There are very appropriate times to use the mean, and I'm very sure that every group or every person's project should have mean values in it somewhere. But sometimes people go, oh, well, I measured the center. I'm done with that. And they move on. When they're not really done, they didn't take a great measure of the center. So the mean is one useful tool. It's not the only tool. So the mean is where we add up all the values, divide by the number of values. So let's say we want to know the mean of this. I could calculate it by hand for 10 values. That's not too hard. I could put them in my calculator, add those up, divide by 10, get my answer, right? That's pretty easy. But when you start having 120 responses, you don't really want to do that by hand. And in reality, when you find data sets now, like you've heard the term big data, your data sets might be thousands to millions of data. And when you start talking about companies like Google and Facebook and Microsoft and Apple, they have data sets that they're so large that it actually becomes difficult to have computers that can like hold the data sets at the same time. So then you get into like a whole different category. You've heard the term big data, where once your data sets are too large to be held by a single computer, then what do? Right? And then they have a whole different set of tools. It's the same tools, but they're using it in more advanced ways to try to do that. But when it's small, we could do it by hand, but why would we, right? Why not just have StatCrunch do it for us? So you come into stats here and see this term called summary stats. This summary stats, you're going to be learning a bunch of summary stats in this chapter. So your mean, your median, your standard deviation, your variance, a bunch of these things are all going to come out in the summary stats. Some statistics books call it a 5-number summary. I actually don't like that term, but it's pretty much embedded in statistics right now. So you may see it known as the 5-number summary. So you go stat, you go down to summary stats, and then we'll go over to columns, and then you have to pick your column. So I only have one column available, and so it's saying that's the only choice. When you do when I give you the data for your survey, you're going to have 100 columns. So you're going to have to figure out which one is your data, and then you go down and choose it, right? So I'm going to choose var1 because that's the one that's at the top, the title. And you can change this too. I could change this to test scores, right? So now it's called test scores, right? So you might want to do that when you're doing yours, because there's actually kind of it's a little bit irritating. The questions in the survey start with question 1, right? But then the data in the when I give you this that has all the data in it, it starts with answer 0. So those of you who have taken computer courses know, or learned computer languages, a lot of times when you're counting things in computer science, you start counting with 0, which seems strange if you've never studied computer science before. So what that means is the number's off by 1. So you want to be real careful when you look at your data. Like, look at the data and go, does this make sense? Is this really the right column? And then make sure that it matches what your question, because sometimes students are off by 1. They look at the column next to it because they match the numbers, and then their data doesn't make sense. But then you can rename it if you want, just like I did here. I changed this to test scores, and then you won't mix it up in the future. Like when you come back to it 3 weeks later to do the next part and go, and then now you're confused. Okay, you can choose what you want it to cover. These are like, it's going to give us a bunch of stuff. If you wanted to do some of these other things, you could throw that in there, but we're not going to do any of that. Like we could throw that in if you just wanted to know the total of all these scores, but that's not particularly useful, right? Why would we do that? So some of this stuff you're going to know already, or will learn in the next couple days, weeks. Some of you don't. N, for this entire class, whenever you see a lowercase n, that's your sample size. Basically, that's how many data points you have in your data set. So if 42 people answered your question and gave an answer, then your n is 42. That's what that's going to represent. Okay. The mean we just talked about. The variance we'll talk about in a little bit. Probably not today. Standard deviation we'll talk about another day. Standard error, we don't really even need standard error for what we're looking at today. And then here's the median. That's the other one. The mean and the median together are the big 2 measures of center. Those are the ones that, like, every single time you ever do statistics on a data set, you should always look at the mean. You should always look at the median. It's not like, oh, I wonder which one's better. You look at both of them, because sometimes you just want to use the mean. Sometimes you just want to use the median. Sometimes you want the mean and the median together, because if there's a difference between the mean and median, sometimes that's very informative. And you go, I wonder why the median is so much larger than the mean. I wonder why that's happening there, right? Your min, that's your minimum value in your set. Your max is the maximum value. And then when we get to quartiles, that's your first quartile and your third quartile. We'll get to that stuff later. So let's say I want to compute this. So let's see, I'll show you. So you go over and I hit compute, and it gives me this. This is my summary. Right? And that's why I don't like when books call it the 5-number summary, because, well, now with software, you can easily just change it to like different stuff. You might go, I don't need the standard error, but I do want to include the sum. You know, it's silly to call it a 5-number summary then. But here we go. N, my N is 10, telling me I have 10 scores. Now I knew that already, but what if this list was like 3,572 data long? I might not know how many are in there. Well, then I would know right here because my N is telling me, right? Here's my mean, 71.2 is the mean. So if I add up all these scores by hand and divide by 10, divide by N, which in this case is 10, I would get 71.2. Okay, the variance, standard deviation we'll talk about later. Then here's the median. What is the median? The median, loosely, like you'll get into the strict definitions of these when you do the lessons, but the median can be thought of as the data value in the middle. A lot of people assume that the mean is always in the middle, but that's not true. The mean can easily not be the value that's in the middle. It's giving you an idea of the center, but not exactly the middle. The median should always divide your data into 2 halves, the top half and the bottom half. That's why I was saying what students usually want to know when they ask the mean is, am I in the top half of the class or the bottom? then if that's what you want to know, then what you should be asking is, what was the median score? Because the median, if you're above the median, yes, you are in the top half. If you were below the median, you are in the bottom half. The median splits it up that way. Okay, so that's great. StatCrunch just gave us that. I didn't have to like crunch a bunch of numbers. So again, you're not useful in statistics because you can crunch numbers. You need to know how to crunch the numbers, but you are useful in statistics because of the interpretations that you can make once you know the mean and the median. That's where it's useful, and that's what's frustrating for some students because that takes that critical thinking component, right? You can't just memorize it and go, oh, I've memorized how to use the mean and median. You may have memorized it for one particular data set, but as soon as we change that data set even slightly, it's a whole new set of thinking you have to go through in order to get through those things, okay? Notice it also gave me my min and my max. My lowest value is 15, highest value is 98. And the range, what is that? The range tells me how much distance there is between the minimum value and the maximum value, okay? So you can kind of see that. 98, our highest value, minus 15, our lowest value, gives me the range, which is 83. That's helpful if you're trying to make some type of visualization and you need to know how spread out does my x-axis need to be, or if it's the, if you're doing it on the y-axis, how tall does this need to be, and you can figure that out because you know your range. Okay, so pretty easy to have StatCrunch go through and calculate that stuff for you. Let me see if there's anything else I want to say. Oh, let's do some more examples. So the mean and median both have strengths and weaknesses. That's why you always want to do both of them and then just see, is one of these more useful than the other right now, or should I even use both of them to when you're doing statistics, you're always trying to develop a narrative about your data set, a story that you can tell someone that you say, this is what I think is going on in this data, and here's what we should do about it. And to do that, you're going to have to use these statistical tools, and you can say, well, here's the mean, here's the median. See how there's a difference between the mean and median, and sometimes that's insightful. So I've given an example a couple times about. Actually, let's save that example. Let's do this one. Let's go. Okay, let's say you decide you want to buy a house, and you go, okay, this is our price range, so we should be looking at houses roughly in this price range, and you want to look at neighborhoods where the home prices are roughly in that neighborhood. Well, it depends on the type of neighborhood. Sometimes you go to some neighborhoods, every house is like exactly the same, so the prices aren't going to change very much. But sometimes you go to neighborhoods, especially older neighborhoods, you might have a big difference in how what the houses are. You might have some big houses, some small houses, some big lots, some small lots, some lots with views, some lots that don't have views. So you're going to see more of a range in the prices. So what you might do is say, ooh, this neighborhood has a mean price value that's close to what we're looking at. That almost never happens in real estate. No one talks about the mean home price. You almost always hear them talk about the median home price. The median home price in this neighborhood, right? And there's a couple of reasons why. Let me give you an example. Let's say okay, so let's say these are houses that are for sale in some neighborhood, and then there's one that's got an extra big lot up on the hill, over it's got a view, and it's worth like 3 times as much as these other ones. So it's going to be, is that right? Did I get the right number of zeros here? Yeah, so it's about 1.5 million, when the rest of these homes are right around about $500,000. Okay, so let's say that your price that you said is, I think we can afford a home that's between 550 and 600,000, and you want to know if this is a good neighborhood for you to go to. Excuse me. So let's run the stats on that. So I'll pick let's just label this home prices. Okay, so we go to stats, go down to summary stats, and I go over to columns. And now I'm going to pick the home prices category, and I want my statistical summary. So I hit compute, and here it has this. Well, look at our mean value, $665,000. Well, we just stated that, we're this hypothetical family that wants home prices between $550,000 and $600,000. So I look at this and go, oh, these houses are too expensive for us. We better skip this neighborhood because, look, we can't even get near that neighborhood. Our max is $600,000. Here the mean is $665,000. We can't afford that. Okay. Well, looking at the prices in the neighborhood, yeah, we can. We can afford almost all the houses in the neighborhood except this one really expensive house. But the mean was misleading to us. The mean made us think that that's not a good neighborhood for us to go buy in. That's why you never hear realtors talk about the mean house price. They talk about the median house price. So one of the drawbacks for the mean is that it is greatly affected by what are called outliers. An outlier is a data point in your data set that is way far apart than the other data points. See how all these data points for our home prices are all pretty close together. They all range from $475,000 to $575,000. They're kind of grouped together. And then we have this one data point that's like totally different, 1.5 million. It's very different. Well, the mean is very susceptible to what we call outliers. That data point drags your mean off to the side. Like I was mentioning earlier with test scores, there's always a couple real low test scores like 5, 4, 0, stuff like that. It brings that whole mean down. It drags it down. So here, like a lot of people think, oh, well, when you take the mean, half people are above that and half people are below. No, look at this. 1, 2, 3, 4, 5, 6. 6 of our 7 home prices are below the mean. So 6/7 of our data set are below the mean. Why? Because this outlier dragged the mean way up. Okay, so that's a problem. If you have data sets that have like one big outlier in it, that one outlier can throw your mean off by enough that it makes it not useful, which is why it's usually not used in home prices because of this problem right here. Notice instead of looking at the mean, what if we had looked at the median and said, instead of looking at home prices and saying, what's the mean home price in this neighborhood? What if we had said, what's the median home price? Well, look over here at the median, $550,000. We go, oh, that's right in our range. In fact, we could even afford a little bit more than that. So this is probably a good neighborhood for us to go look at. Why is that? Because the median is not as affected by outliers as the mean is. So when you're asking the question, for my question, should I use the mean or median? One consideration is, do you have outliers in your data set? If the answer is yes, then you may not want to use the mean. There are other cases where you may not want to use the median. It just depends on every question's a little bit different. But notice how the mean led us to believe we should not look at homes in this neighborhood. The median led us to believe that we should look at homes in this neighborhood. And sure enough, when we go there, we're happy with all these prices. We go, oh yeah, we could buy a number of these different houses here. Right? In fact, we could buy 6 of the 7 houses that are for sale in this neighborhood. We just can't get that big expensive one. Right? We can't afford that one. Okay, so that's why we can see there's already 2 measures of center, which it's not that one's better than the other or that you should always use one over the other. In every situation, you should look at the mean and the median and go, which one do I think is more appropriate for this problem? And like I say, even sometimes you'll give both. You'll talk about both the mean and the median. And see, like here's a clue. If you ever see a big difference between your mean and your median, like we're seeing here, the mean is not really close to the median. That's actually an indicator that you might have an outlier in your data, right? Not necessarily, but it might be. So if you're looking at data and your mean and median are far from each other, you might look closer and go, oh, look, I do have an outlier. I have this one value that's very different than my other values, right? the first time I did the stats project in class, one of the questions that people asked was age. Almost everyone always asks about age. But, most students are right around early 20s. 18 to 22 is where most of our students fall. But we had a student in that class that I think was right around 70. So that definitely skewed that data. It made it, if we looked at the mean, I forget what it was, but the mean was like 25 or 26 or something at that point. But almost everyone was below the mean. That's because we had one outlier with a much larger age that was pulling that mean in one direction. Okay, so this is why I know it's not as satisfying. You have to be flexible when you deal with statistics. It's not like what you should not walk away from this class thinking is, oh, the median's always better than the mean, right? No, that's not what I'm saying at all. What I'm saying is for every question, every data set you deal with, it's different. Sometimes the mean is the right measurement. Sometimes the median is the right measurement. Sometimes you want to use both, and sometimes that's the right measurement. So I know that's kind of frustrating because then you're like, well, I can't just memorize that, right? That's why statistics is tricky. You have to think your way through every single problem, right? You can't just kind of go on autopilot like you can do in algebra when you learn how to solve by factoring, and you're just kind of like, yeah, I can do a million of these, whatever. In statistics, you actually have to critically think every single problem that you do, which can be frustrating. So that's the mean and median. Those are the main measures of center that we're going to use. There's a couple other measures of center that'll come up, but those are the big ones. So let me just make sure I didn't miss anything here. One thing about the mean is it uses every single data set. So that's a strength and a weakness, right? Your mean uses, in the calculation, it uses every data point, but that's also the problem because it also uses the outlier, and that's why that outlier can skew it one direction. So, and the drawback is that it can be affected by outliers. And then let's see, where's the median? The median is less affected by outliers. So if you do have an extreme outlier in and we'll talk more about outliers later, we'll define exactly what an outlier is. But if you have a value that looks like it's probably an outlier affecting your measures, the median is usually a better choice in that situation. Like the example I just gave, we have this outlier house price, and the median was the better way to measure that neighborhood, right? More than the mean. So if you have an outlier, start wondering, maybe the mean's better in this situation. And the median does not directly use every single data value. You'll see the calculation when you watch the videos, which is why it's not affected by outliers, because it doesn't use the outlier in its calculation, which is helpful. One thing that's nice is the median is always going to be either a data value or close to a data value. Your mean, like see this mean we got here? None of our home prices are like that. 665,000 is not even close to anything. It's well above these low prices, and it's well above the high price. So nothing's near the mean, but the median, you should always have some data values that are pretty close to the median. That's one of the useful things about the median, okay? A couple minutes here. Then you have the mode. The mode is just the number that comes up the most times. Not helpful, right? I shouldn't say that. That's a blanket statement. We won't use it very much. Okay, the mode can be helpful sometimes, but it's in very limited situations where you would care about the mode. If we took the ages of people in this class, we might get that 18 is the mode, right? Okay, well that's good, but how helpful is that really going to be for us, considering there's still a bunch of 19-year-olds and 20-year-olds? It might be helpful. I'm not saying never use the mode, but it's a measurement we take, but not as helpful. The mid-range is also not that helpful. That's just a way of measuring the center, but that's almost never useful, so you don't really have to worry about that very much. And then just think about what makes sense to take the mean and median of, and it comes back to those data values, right? You're generally taking the mean of quantitative data. And I know some people are still confused on those names. Quantitative, quantity. A quantity of something is a number of something. You're counting something. your data needs to be quantitative. If we took the mean of everyone's ages in this class, would that make sense? Yeah, that makes sense. If we took the mean of everyone's phone number, would that make sense? No, doesn't make any sense. Okay, so just think about, and this is true for everything we do in this class. Before you do a calculation, ask yourself, does this make any sense? And if the answer is no, then don't do it, right? Don't do a thing that doesn't make sense. Okay, I think that's a good place to stop. So you got your first view at StatCrunch. I would recommend try to get into StatCrunch and just play around with it a little bit. It's going to be a tool that you're going to use to help you greatly on your project. Just make sure you can get in there and play around with it. And if not, get together with your group and figure out if you can figure out how to use StatCrunch and make sense of it. It's going to make your life a lot easier. And then sometimes you can link to StatCrunch from right within a problem. I forget if it's still a little box with a line through it. On the other software I used, it used to be on the questions, they'd have a little box with a line through it, like a link. It was blue, like a link. And if you clicked it, it would open up that problem in StatCrunch, which is nice because it'll populate a column with your data. You don't even have to like enter the data into the problem. It'll be there already, which is really nice. You don't have to spend 5 minutes copying the data over. It'll be there. So just look out for that. Look for that little link. Not every problem's going to have it, but some problems will have a link where it opens it in StatCrunch for you, and you just work on it. Okay? Okay, with that, looks like we're out of time. So we'll stop there. We'll continue our discussion next time. So let me close down the